Yunis Alamansu. The title of the paper is Multi-Scale Vehicle Localization in Underground Parking Lots by Integration of Dead Reckoning, Wi-Fi, and Vision. Okay, thank you. You can start.
Good afternoon, sir, everyone. My papers about multi-scale vehicle localization underground parking lots, integrated dead reckoning and Wi-Fi and vision. The outline, introduction, and the technical road methods, result, and conclusion. The background, we know the vehicle localization in underground is new direction for intelligent transport, and the GPS have limitation in indoor but is good for outdoor. In underground they have more technical already used now, but some of this technical have you need to adjust in the environment and cost and the accuracy. For that our method, we try to integrate the Wi-Fi and the DR and the vision. The Wi-Fi is good about 2 to 5, some research they said about 2 to 10 meters, but with the multi-path they have impact with the wall, and for that we try to integrate the rotation by the DR accuracy about 2 to 5 meters, but they have drifting with the long time, and if you have long place, and the DR need initial position. The vision is the best for indoor, but the problem for vision based in the curve in underground parking lot with the vehicle. They have limitation and no visible in the curve. Like this in the curve, if you see here in the car, they cannot, the vision is clear to calculate the day, but in another side is good. With the light, if the light change, you cannot make future to distinction from the image. From the Wi-Fi, you can see here the display, and you know the Wi-Fi have increase and do increase with the time and with the place. The proposed method integrate the vehicle for the vehicle localization in the curve, because the vehicle have problem in the curve. We try with the integrate the DR to get the orientation and the Wi-Fi fingerprints. That's motivation for our papers. Our method, they have 3 steps, is called the multi-scale localization. In the first one is DR to indicate the orientation by curve. Then by Wi-Fi fingerprint we get the course localization. The last is the image level localization. We get the features image between the offline and online, and then we by matrix localization we get all the result to integrate to get the last result. This is the technical road search how our technical. The first is the offline stage and the online stage. In the offline stage, we get the Wi-Fi fingerprints. From the Wi-Fi, we get the RSSI MAC address and store this in map generation. The second one, from the pavement image, we collect the RB features to calculate and store in the map. In the online stage is called the multi-scale localization. The multi-scale localization is from the acceleration data and the gyroscope data. We calculate all of them and we get the alteration. If they have some error, we calculate again, return. And the second step, if from the Wi-Fi, we calculate the data from the map generation and from the query image, and make the features together, the fingerprint from the Wi-Fi in the map and the Wi-Fi from the query, and by KNN we calculate the distance. This step is the coarse localization method. The second step is the image level localization. The features, the image pavement from the offline and the online, we make matching by ORB and we collect the closest image. The last stage is the matrix localization. We calculate by the RANSEC and with the coordinate, because the coordinate is actually 100% without errors. For that, we compare between the coordinate and with the result from all the stage, and delete the matching error by run sec, and then we calculate the last result. The methodology map correlation first with the pavement image with dedication and URB, and from the Wi-Fi we get the matrix address. This the symbol. This the our place, Wanda Plaza first floor and the second floor in underground, and this the symbol how we show the result from the course localization, the first stage. How collect the data, and the Wi-Fi features, we get the Wi-Fi from the map, and we make for every location, and by this equation we can, by main filter, we delete the errors. And from the pavement image we make the dedication of the first K point from the every pavement image, and we calculate it by URB description and store this to batch by this equation, and they have more steps about URB. You explain this in the paper. The localization stage is the course localization. They have three. One the course localization direction change from the DR and the Wi-Fi, and the second by ORB calculate the features and matching. The last one is the run sec, we calculate the homography and the boss. The first one, from DR we calculate the acceleration data and the gyroscope data. By complementary filter we can delete the errors and get the direction, because the acceleration data he give us for a long time, but the gyroscope for the curve. The Wi-Fi fingerprint in the localization stage, we get the Wi-Fi fingerprint from the map, from the offline, and the Wi-Fi from the online, and by this method we make the matching the Wi-Fi and to collect what is the best for the location. From the vision, same, we have the matching in the image from the map generation and with the localization stage, and we get the features, and by URB we get is the best features, and we collect the closest image, and by Hamming distance we calculate this basement the image from the location. With the run sec we calculate with the coordinates to delete the false error. The experiment result from the DR, this for the first floor and the second floor from the complementary filter after the acceleration data and gyroscope data. And from the Wi-Fi we calculate the data in morning and afternoon and in, night. We saw the result like this. The same the location we have changed the data bandwidth of the RSSI. Same the location is different. This is the data set for result. Example, for the first location we get the RSSI, and for how many EBBI for access point for the every location. This for first scenario and second scenario, and this is the result for that data set. The A and the B is for first floor, and the C and D is the second floor. From A and C we calculate the Wi-Fi numbers for every location, how many Wi-Fi's, and we calculate all the totals. And this D and B we calculate the Wi-Fi signal for every location. This the Wi-Fi result. We see the key value after in the 3 we get 78, but in the 7 in the first scenario we get 98, and the second scenario we get from the 170, but in 6 we get 96. For the vision based we have two stage in the image level localization and the matrix level localization. In the image level localization we get the matching. This is the before test from the training data and after test in localization stage, and we saw the frame error from the first and the second after matching, and get the result and the percentage for every step. This is the image level localization. This is the flowchart, the figure after that data set we show last time. Last slide, the frame error. For the matrix localization, after the matrix localization, we get the run seq after the delete error from all that's the frame error. We get this the last result on the percentage is about 96 for first floor and 98 for the second floor. This is the last result for the first one and the second one, and integrate the result after the CDF. The conclusion about this paper, we proposed the method integrate the DR and Wi-Fi and pavement image. These two map in the localization, and we compare it with the 3D coordinate to so the create the position. Our result of this paper about 96 success rate with the localization error average under 1 meters. Thanks for listening. And
Okay, thank you very much for Eunice. And I think this work is about the fusion of different kinds of sensors, and including the vision-based, Wi-Fi-based. I think it's very interesting, and with you know, the vision of the future research. My question is, the first, is this project connected with some real applications? I find that you have done your experiments in the Vanda Plaza. Is it used for a navigation of the indoor, especially for the mall plaza?
yes, sir. We have EBB.
Okay. Yeah, in my opinion, vision-based is enough. Why we need to incorporate Wi-Fi? Because in the you know, the shopping mall or plaza, the vision, I think, is sufficient. Especially using the Wi-Fi means there are you know, some of the multi paths, and you know, also have some very dark environment. We can use that Wi-Fi. Or if not, I think vision-based is enough. Why we use Wi-Fi?
You're right, Prof. But that's my motivation. I solve the problem in the curve, only in the curve. We have big problem in the drift in the curve when you collect the data in the curve, height error from the vision based. And
Okay.
and
And the Wi-Fi using. Okay.
Yeah, you can.
And using the Wi-Fi, as we know, we have many methods on Wi-Fi fingerprints. For example, we can use the CSI based. Why we use the RSSI based? According to our evaluations, we all know that the RSSI is very inaccurate. Even there is a great number of APs presented, but RSSI is really unstable and has large errors. Why we do not use CSI based?
Yeah,
CSI, channel information. Yeah.
Yeah, I just use KNN and this method because just for improve, not final. Just
Okay.
for improve, not for
Hopefully we can
result.
see your improvements at work on MobiCom 2021.
Yeah, you're right. We can do it for future. Yes, sir.
Okay, thank you, Eunice.
Thanks.
Thank you, Eunice, for your wonderful talk. Okay. Any questions? Any questions for the audience? Sorry for not asking for the audience. Okay. Thank you. Let's move to the third one. The presenter is, I think, it's Xu Yue. The title is HD Scatter, Improving the Hardware Design of Advanced Backscattering System. Let's welcome Xu Yue.